Good afternoon to all of you. Welcome to this third live session for the course Fundamentals of Convective Heat Transfer. So if you have any queries, you please post it here. So one query we have received regarding the question paper in the final exam. So the question paper will be similar to the assignment questions, whatever you have already solved while running the course. So there may be MCQ type question, true or false, and also you have to calculate the value and you have to write the numerical value in the given space. So these are the these are the types of questions whatever already you have encountered during solving the assignment questions. So similar type of questions will be there in the final examination. Okay, so Mohan is asking, can you please differentiate between advection and convection? So if you remember, means in the module 1, we have already discussed about this, that advection refers to the heat transfer due to bulk motion of the fluid, right? And if you see the fluid which is sitting on the top of the hot surface, so obviously from the surface to the adjacent, the first layer of the fluid, heat transfer takes place due to conduction, right? So after that the advection takes place due to bulk motion of the fluid. So convection is the combination of these two, conduction as well as advection. Okay, so these are the difference. So advection is the just heat transfer due to bulk motion of the fluid from one place to another. But if there is a hot surface is there, so from the hot surface due to conduction from the solid surface to the adjacent liquid on the top of this surface, so heat transfer will take place. So these both together is known as convection. There is another question posted that how do you determine the critical Reynolds number? Okay, where the means fluid flow takes place from laminar to turbulent region. So obviously, if you apart from the experiments, okay, then you have to measure the some quantities like velocity and how it varies with time. And if you do numerical experiment, also the same thing. So if you measure at a particular point these velocities with time, then obviously you will see that in the laminar region there will be a smooth variation of this any quantity like velocity, pressure or temperature. But if it comes to the turbulent region, then obviously there will be fluctuation in these quantities with time. So and also if you visualize the flow phenomena, obviously in internal flows it is very difficult to visualize the phenomena. But if it is say external flow like flow over a flat plate, then obviously from the top you can observe how the fluid velocity is going. So if it is a very smooth flow, then obviously you can see that it is a laminar flow, and if it becomes very chaotic motion, then obviously it becomes turbulent flows. So obviously it is means it depends. You cannot exactly pinpoint that it is whether 2300 or whether it is 5 into 10 to the power 5 for a external flow for flow over flat plate. But it depends on the surface morphology. Say if it is a very smooth surface, then experimentally it is found that Reynolds number 2300 is the critical Reynolds number for flow through circular pipe, and critical Reynolds number is 5 into 10 to the power 5 for a smooth for a flow over a smooth flat plate. Okay, and there is another question that can you tell marks distribution in final exam, how like how many MCQ will be there, how many problems and their marks. So there will be total 50 questions. Each question carries 2 marks. Okay, and some questions will take very less time, but some question may take some more time because you need to find a value or derive something. So it might take more time, but overall it will not take more than 3 hours. Okay, so but total there will be total 50 marks, and each question will carry 2 marks. Okay, okay, so there is another question that if let's say fluid flowing in environment and there is only advection, am I correct? So if you can see that if you don't consider the earth surface, okay, but then obviously you can say that only advection is taking place due to the bulk motion of the fluid, but obviously this means the fluid whatever you are considering, those actually are having effect from the surface, right? Then only the heat transfer is taking place. Okay, so there will be always means there will be effect from the surface which is due to convection, and those fluid when it is flowing through due to bulk motion of the fluid, then advection is taking place, then combinedly we are telling as convection. Okay, so you cannot actually cannot consider, if you are considering obviously the heat transfer, then from the solid surface the means due to the temperature difference of the solid surface and the flowing fluid, heat transfer takes place. So when you are considering convection, it is combination of these two, conduction as well as advection. There is another question. Can you suggest book or explain numerical algorithm for coupled differential equation in natural convection over vertical plate? So when you are considering natural convection over a vertical plate, obviously you can solve in 2 different ways. If you see in this course, analytically we have solved, right? So we have boundary layer equations, and that boundary layer equations for means Navier-Stokes equation as well as energy equation, that analytically you can solve. But if you want to adopt numerical simulation, then both ways you can do. Either you can solve these boundary layer equations, okay, and you have to march in y direction if it is a vertical plate, and if you are moving from say obviously there is if it is only natural or free convection, so and if the plate is hot, then your this lower density fluid will go up, right? So obviously you can see that there will be a convection current in the upward direction, so you have to march from the bottom of the plate to the means bottom of the vertical plate to the top of the vertical plate. So these boundary layer equation if you solve, then it is, you can see that boundary layer equation is parabolic in nature. Okay, so you have to march in a in y direction. If y is the along the vertical plate, then in y direction you have to march. That means at y is equal to 0, let us say at the inlet. So from there you have to just march in y direction, and at every layer of y you have to get the velocity. So this is one way, but other way is that you solve full Navier-Stokes equation in the domain, and now you have both, because Navier-Stokes equation when you are solving, then obviously you have the buoyancy term, right, where temperature is involved, and when you are solving energy equation, then obviously you have velocities. So you can see both way these are coupled, right? So when you are solving the Navier-Stokes equation, it depends on temperature, and when you are solving energy equation, it depends on velocity. So these are two-way coupled. So when you are solving this boundary layer equation or the full Navier-Stokes equation, you need to solve these equations together. Okay, so in one loop you have to converge this Navier-Stokes equation as well as the energy equation, and you have to go to the next time step, or if you are solving a steady state, then next iteration level you have to move. So this way you can numerically solve this problem, natural convection over a vertical plate. So Mohan is asking that I am asking for sake of understanding that environmental flow without considering earth surface, whether it is advection or convection, just consider to understand advection. Yes, it is a movement of a bulk fluid, then you can consider it as advection. Now you are asking that, sir, can it be solved by shooting methods? So now if you are talking about this numerical methods, that means whatever using the similarity variable approach, we have solved this free convection, and we have derived the ordinary differential equation, right? So when you are solving the ordinary differential equation, so you can actually coupled way both energy equation as well as the means the ordinary differential equation which you derived from the boundary layer equation. So that coupled way you can solve using Runge-Kutta method, and shooting technique is used. That time you can use shooting technique because I have discussed about the boundary conditions in the course. So to satisfy those conditions, you can use shooting method. Okay, so if you are solving the ordinary differential equation, but if you are solving a partial differential equation, which actually your boundary layer equations or Navier-Stokes equations, then obviously some numerical technique like finite difference method or finite volume method you can use, and you can discretize the domain, and at every discrete point you can solve these discretized equations. But if you are solving the ordinary differential equation which we derived using this similarity approach, then obviously that you can use Runge-Kutta method along with the shooting technique. So whatever Mohan is asking that if let us take fluid flowing and they will collide each other during this contact, this will be there will be heat transfer. What kind of heat transfer is this? Where can we add the phenomena whether with convection or conduction? So obviously in this case, when you are considering that two fluid are coming at different temperature, so obviously you can consider as advection because there will be mixing. Okay, and due to mixing, obviously you can see that some equilibrium temperature will reach. Okay, so when two fluids are colliding, having different temperature, so obviously it will mix and there are two fluids or same fluid with uh, So it will be of same fluid, obviously. Then that can be that can mix, or miscible fluids if you consider. Then obviously it will mix. Then it will reach on equilibrium temperature. So obviously this you can consider as advection, because there is no heat transfer is taking place from the surface. Another question was asked by Sabir Hassan. I do not know what you are asking. You are telling that I want to know about the film regimes. So are you talking about the in the boiling this film regime? It is not clear from your question. So if you are online, you please elaborate your question. So can you provide the algorithm of shooting method for that derived differential equation? So that you can write on your own. So you have to say you can means see the book of fluid mechanics by Som Biswas and Chakraborty. Okay, so there this shooting technique, how to approach the full algorithm is given. Okay, so you can follow that, or in the book of these fundamentals of convective heat transfer by Biswas, Dalal and Dhir. In that book also it is given, but obviously that book is very costly because we have the international version of this book. So there also the detailed technique is given. So what I do, I'll just post it in discussion forum. Okay, so I'll post it in the discussion forum so that all of you can see. Okay, how to actually use this shooting technique for solving these ordinary differential equations. So the questions asked by Sabir Hossain, that I want to know about film regime. Say when you are considering boiling, so you have seen that there are different regimes. When you have this superheat, you are increasing. So obviously you can see that from natural convection, then nucleate boiling, transition regime, then film regime. Obviously in the film regime, you can see that the vapor blanket is formed over the surface and heat transfer decreases. So that's why you will see that in the heat flux curve it will decrease with increase in superheat. After certain superheat, then again you will see that again it will start increasing. So that point is known as Leiden-Frost point. Okay, minimum heat flux point. Okay, Leiden-Frost point. So after that it will start again increasing. Why? Because the temperature becomes so high, because due to increase in the means temperature difference. So obviously the surface temperature increases, and the radiation mode of heat transfer is dominant, and again heat flux starts increasing. Okay, in the film regime of boiling. Yes, solution of assignment will be posted soon. I have already discussed with the teaching assistant. So they will be posting, already they have posted earlier solution of assignment. So now whatever is left, they are going to post, okay, the solutions. So when you are talking about this two solid surface or fluid interface of two immiscible fluids. Okay. So when you are considering two immiscible fluids, so obviously the heat transfer will takes place, but uh, you can means your question is that whether we will say convection or advection, right? Because there is no solid surface, right? So in that case obviously you can consider as advection because there will be only the bulk motion of the fluid, and you can see when you are considering only two fluids, okay, of same liquid or miscible or immiscible, obviously you cannot define Nusselt number. Okay, if surface is present and only you can calculate the Nusselt number on the surface only, which is the measure of heat flux or heat transfer rate. Okay, so if there are only means mixing is taking place or of two miscible fluids or due to these two immiscible fluids at the interface, then obviously there is means you cannot define Nusselt number there. Okay, because you know the definition of Nusselt number, right? So you can see that means in the presence of solid surface only you can calculate the heat transfer rate. So in these cases you can calculate the final mixing temperature, okay, or means because you can just for different species whatever you have. I discussed I think these things in the last live session. So there obviously the mixing will takes place, and that obviously you can say that due to advection the means there will be temperature difference, but obviously in equilibrium same temperature will be there in both the fluids. So you are asking about conductivity of fluid represents that ability of conduct heat from a solid surface only if it does not represent the conduction of heat from one fluid's molecule to another fluid molecule of same kind. No, obviously it can. Okay, because you have seen that in the Nebius in the energy equation, in the left hand side we have advection term. Okay, right hand side we have diffusion term. Okay, so in the diffusion term where you have k into get square t. So now you have to understand what we are telling. So when two different fluids are there of different temperature, okay, when they are colliding, so there will be kind of mixing or it will exchange heat, but mostly this diffusion you can see that most of the time we neglect because the that will be very less compared to the others compared to the advection term, okay, when the fluid is in motion. Okay, so obviously there will be diffusion, okay, in the fluid medium, okay, the heat will be diffused obviously, so due to the presence of thermal conductivity, right? But what we are telling that how we'll measure this heat transfer rate? Is there any way that what is the heat transfer rate due to that? Because you don't have any reference surface from where you can actually measure that, right? To measure the heat flux or to measure the heat transfer rate or to calculate the Nusselt number, you need the presence of any solid surface where you have at higher temperature, lower temperature than the fluid, right? But what you are talking, obviously, when it is moving, when the bulk motion is happening, obviously the diffusion is taking place. But depending on the fluid conductivity, the magnitude will be less or more, so it depends. But most of the time you can see that in axial heat conduction always we neglect, right? You have seen that when we consider the flow over a flat plate, means we have some assumptions because it is very small compared to the others, and we can neglect. But what is important, if you remember that we have seen that in the normal direction of the surface, obviously this diffusion is important because there is a presence of solid surface, right? But when you are mixing of two fluids, okay, so mostly you will talk about the thermodynamics point of view, and in terms of heat transfer, obviously you don't have any reference thing to measure the heat flux or heat transfer rate, so that I am talking about. No, when we are talking about conduction, so I'm talking about conduction from the solid surface to the immediate layer of the fluid. But when we are considering diffusion, so in the fluid medium, so obviously in the energy equation you have seen, even not only means in the energy equation, if you see in the Navier-Stokes equation, you have a viscous term, right? Which is kind of diffusion of that, right? And in the if you consider energy equation, obviously you have thermal conductivity into means grad square T, which is known as diffusion term. So in the fluid motion, obviously there will be means diffusion. So you are asking that if you take out water bottle from refrigerator, condensation occurs at the surface of the bottle, and we see condensate as water. So from where it came, it is due to porosity of water bottle surface. No, no, no. So you are correct that it is due to the condensation. So when you are bringing this water bottle or the cold drinks bottle out of this fridge and keeping in the ambient, so obviously its temperature is very low, right, compared to the ambient temperature. So condensation takes place, and this condensate actually forms the liquid drops on the bottle surface. It is not coming from the inside, inside of the bottle. Mohan, so you are asking that there is conduction between fluid molecules, but it is negligible. So we say that it is only advection. Sorry, sir. So you can see. It depends. No, always it is not negligible. You have to see that in which direction it is negligible. So as I told, that when we consider flow over a hot flat plate, in axial direction we neglect the diffusion, okay, but in normal direction we cannot, okay, because there will be a temperature gradient, and from there you will get also the diffusion, because you can see that from the solid surface to the next layer of the fluid there will be conduction. Then after that, obviously due to bulk motion of the fluid and due to the diffusion, there will be temperature gradient, right, and thermal boundary layer forms, okay. So but the axial heat conduction, you can see that obviously that is very small compared to the conduction in normal direction, so that time we neglect it. Okay, so you are asking that source of condensate, since water molecules is combination of hydrogen and oxygen. No, you can see that moisture is present in the air, right? The whatever moisture is present in the air or the ambient, actually that is becoming the condensate over the means cold surface. Okay, so that is already means present. Only it is means condensating over the cold surface. So you are asking what about other elements? Other elements means obviously whatever say this moisture is there. Okay, so those actually this latent heat of condensation. Okay, so due to the means heat exchange, there will be latent heat of condensation. So that actually it converts the moisture to the liquid, okay, but other elements it doesn't change, so there is no reaction taking place, okay. You have to remember that there are no reactions taking place, only it is changing its state. In energy equation, balance equation, there is a diffusion term, okay, and it represents heat transfer from solid surface, am I right? No, because when you are considering a fluid medium, and inside fluid medium, if you are considering one means elemental volume, and if you are doing the energy balance, that time you cannot. But overall heat means in the that time means from the solid surface there is no heat transfer we are considering. But yes, you are correct. So if you remember when in the I think module 2 when we actually derived the energy balance, so you can see that we have taken the heat transfer from the solid surface in the energy balance. Right, you are correct. But that we did for the internal flows. Okay, that we did for the internal flows. Okay, so if there are no questions, okay, thank you very much. If you have further any question, you please post it in the discussion forum, and I will post the shooting technique, how to write the code in the discussion forum. Thank you very much.